In today's lesson, we'll be learning how to convert standard form to factored form. More specifically, we'll be learning how to factor a difference of squares. Take a look at this quadratic relation in standard form. It is in light gray font. Let's start by analyzing it. The last value in standard form tells you the y-intercept. So the y-intercept is -4. And the coefficient of x squared in standard form tells you the direction of opening. Since this is a hidden +1, that means your parabola is going to be opening upwards or smiling. Because the coefficient of x is 0, that means 0 times x just becomes 0, and that disappears. That's why it can be simplified to just y equals x squared minus 4. I want you to imagine this term, x squared, as the area of this imaginary square. What would the side lengths be of this square? Well, the side lengths would have to be x and x, because x times itself becomes x squared. Once again, I want you to imagine this term, 4, is the area of this imaginary square. I want you to try and figure out the side lengths of this square. It would have to be 2 and 2, because 2 times 2 equals 4. I'm going to place the side length of x right over here, and I'm going to place the side length of 2 over here and over here. Therefore, the equation of this quadratic relation in factored form is y equals x plus 2 multiplied by x minus 2. And the x-intercepts would be -2 and +2. We already know the x-intercepts are -2 and +2. From before, we know that the y-intercept is -4. If I do a rough sketch, my parabola would look like that. In our second example, I want you to once again take a look at this quadratic relation in standard form. Let's begin by analyzing it. The last value in standard form tells you the y-intercept. So the y-intercept is going to be -36, and the coefficient of x squared will tell you the direction of opening. Since this is +4, that means the parabola is going to be opening upwards or smiling. And since the coefficient of x over here is 0, 0 times x becomes 0, and that's why it disappears from the equation down below. I want you to focus on this term over here, 4x squared. I want you to imagine the area of this square to be 4x squared. What would its side lengths have to be? Well, the side lengths would have to be 2x and 2x, because 2x times 2x gives you 4x squared. Next, take a look at this term over here. I want you to place that here and imagine that the area of this square is 36. What would the side lengths have to be? The side lengths would have to be 6 and 6, because 6 times 6 is 36. I want you to place the side length of 2x over here and over here, and I want you to place the side length of 6 over here and over here. Therefore, the equation of this quadratic relation in factored form is 2x plus 6 multiplied by 2x minus 6. This equation can actually be further factored, but that's a discussion for a different day. Over on the right, I've written out how to find the x-intercepts with the proper method. So therefore, the x-intercepts would be -3 and +3. Since we know the x-intercepts are -3 and +3, let's plot that over here, and we know the y-intercept is -36 from before. And if I do a rough sketch of a parabola through these x-intercepts and y-intercepts, our quadratic relation will look like that.